Hello and welcome to InsideWi-Fi, Video 6. RF System and its Components. Behind every Wi-Fi device is an RF system silently turning data into invisible radio waves that travel through the air across 2.4, 5 and 6 GHz bands. RF modules are essential components in modern wireless communication systems. What is an RF module? A radio frequency module is a compact electronic device designed to handle wireless communication at specific radio frequencies. It typically includes a transmitter, a receiver or both, along with supporting circuitry such as oscillators, amplifiers, filters and antennas or antenna interfaces. The basic function of an RF module is to convert electrical signals into radio waves for transmission and to convert received radio waves back into electrical signals. Why the RF system matters. While the MAC layer handles the logic of wireless communication, the RF system handles the physics behind it. It is responsible for generating, transmitting, receiving and maintaining clean radio signals through the air. Even the most advanced Wi-Fi standards such as Wi-Fi 6E and Wi-Fi 7 cannot achieve their promised speeds if the RF system is poorly designed. Issues like high thermal noise, signal interference, poor antenna isolation, inadequate filtering, or weak amplification can severely degrade signal quality, reduce range, increase packet loss and limit overall network performance. In short, the RF system determines how efficiently a device can convert theoretical wireless capabilities into real-world performance. The core components of a Wi-Fi RF system are signal sources, amplifiers, filters, mixers, attenuators, couplers and splitters, switches, cables and connectors, antennas, signal sources. Every RF chain starts with a signal source, which produces the initial electrical signal that will later be transmitted. In a Wi-Fi RF system, oscillators generate a stable reference frequency. This signal is the heartbeat used to build all RF communication. Amplifiers. Amplifiers in a Wi-Fi chip are key RF components that control the strength of wireless signals during transmission and reception. Amplifiers are used in two main places. Power amplifier on the transmit side boosts the outgoing signal before it is sent to the antenna. It also ensures the Wi-Fi signal can travel longer distances. Without the power amplifier, the Wi-Fi signal would be too weak to reach the router or client reliably. Low noise amplifier on the receive side amplifies very weak incoming signals from the antenna, adds minimal extra noise. This improves sensitivity and helps detect distant, or weak devices. Without the low noise amplifier, weak Wi-Fi signals would get lost in noise. Amplifiers improve range, improve signal quality, reduces packet loss and enable stable high-speed communication. Filters. RF signals are vulnerable to interference from other frequencies. Filters are gatekeepers that guarantee that only the appropriate signals can get through. Filters are used for selecting the desired frequency band and rejecting unwanted noise. Some of the common types of filters are low-pass filters, permit signals below a specific frequency to pass through. High-pass filters, permit signals above a specific frequency. Band-pass filters, permit only a certain range of frequencies. Band-stop filters, block a certain frequency range. Mixers. Mixers serve as the translators and are crucial components that combine two signals to generate new frequencies, the sum and difference of the originals. This process is known as frequency conversion. Mixers are valuable for both transmitters and receivers. In transmitters, they upconvert a low frequency signal to a higher frequency for transmission. In contrast, in receivers, they down-convert high frequency signals to lower frequencies, making them easier to process. Attenuators. Oftentimes, signals can be extremely strong, risking damage to sensitive components or causing distortion. Attenuators reduce signal power to a safe, manageable level. They are often used during testing, calibration, and measurement to guarantee the accuracy of equipment. Couplers and splitters. Directional couplers and power splitters are designed for dividing or sampling signals without causing any disruptions to the main signal path. Directional coupler samples a portion of the power in one direction, used for monitoring or feedback. Power splitter or combiner splits one signal into several paths or combines several signals into one. Switches. RF switches route signals between various paths within a system. They play a crucial role in multi-channel systems, permitting one input to connect to various outputs, or vice versa. For instance, a radar system might utilize RF switches to alternate between different antennas or signal processing circuits. Cables and connectors. RF cables and connectors are vital for maintaining signal integrity. Cables transport high-frequency signals with minimal loss, typically consisting of coaxial structures to prevent interference. Connectors, such as SMA, BNC, or N-type, guarantee reliable physical and electrical connections between components. Antennas, Antennas are the bridge that connects electronic signals and electromagnetic waves. Antennas transform electrical signals into radio waves for transmission and vice versa for reception. There are endless types of antennas available and each of them is designed for a particular purpose. Let me know your thoughts in the comments if you found this video informative and helpful. In the next video, let's see radio wave propagation characteristics. Thank you for watching.